To solve for a statically indeterminate beam, we may use force method. In this example, we have a prop cantilever with 1 degree of indeterminacy. The beam section is prismatic and the entire beam is homogeneous. In this case, usual equilibrium equations do not solve for all unknown reactions. Based on force method theory, the number of reactions to be made redundant equals to the degree of indeterminacy. Our beam is having 1 degree of indeterminacy and therefore we should make one reaction force redundant. Let us make By as our redundant reaction. By making a reaction force redundant, we establish two analysis cases. The cases revolve around a primary structure, which resembles the structure after removing the redundant reaction. The first case applies original loading on the primary structure. The second case applies redundant reaction as an external load. From each analysis case, we need to determine the beam deflection at the location of redundant reaction. At this point, the deflection of primary structure due to original loading is counteracted by redundant reaction. Their sum should equal to the deflection on the actual structure at the same location. From the second analysis case, we determine the counteracting deformation FBB due to a unit of force. The subscript BB denotes that we are interested in the deflection at B due to a unit load exerted at point B. By substituting these deflections into a compatibility equation, we can solve for the magnitude of redundant reaction that produces desirable counteracting deformation. Our primary structure is a cantilever beam. The beam deflection due to both original and redundant force can be calculated using various methods. For first analysis case, we have solved for the free end deflection in our previous video on moment area and conjugate beam methods. So let's take the expression for deflection here. We may use any of those methods to solve for the free end deflection under second case. In this example, we simply refer to readily available deflection formula. Note that the sign for the expression is opposite to that for first case, as the deflection under both cases are in opposite direction. After knowing the free end deflection for both analysis cases, let's deploy our compatibility equation. Since the support B does not settle, the actual deflection on the left-hand side of compatibility equation is 0. By substituting the results from analysis cases, we left only one unknown By. After By is solved, we substitute it back to our original structure. At this point, we can solve for remaining support reactions by using equilibrium equations. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.